Measures of dispersion. First, we are going to see a definition of dispersion. In the words of Bowley, dispersion is the measure of the variation of the items. According to Connell, dispersion is a measure of the extent to which the individual items vary. Measures of dispersion are descriptive statistics that describe how similar a set of scores are to each other. The more similar the scores are to each other, the lower the measures of dispersion will be. The less similar the scores are to each other, the higher the measures of dispersion will be. In general, the more spread out a distribution is, the larger the measure of dispersion will be. Which of the distributions of the scores has the larger dispersions? The upper distribution has more dispersion because the scores are more spread out. That is, they are less similar. You can see in this diagram itself here, which of these distributions of the scores has the larger dispersion. While seeing the diagram, you can see, okay, how the larger distributions are the variations. The upper distribution has more dispersion because the scores are more spread out. That is, they are less similar to each other. Methods of dispersion. The following are the main methods of measuring the dispersion: range, interquartile range and quartile deviation, mean deviation, standard deviation, coefficient of variation, Lorentz curve, range. So range is nothing but the difference between largest value and smallest value in a given set of data. That is called as range. See here, what is the range of the following data? Here you can see which is the highest value, which is the largest value, smallest value. So highest value 9, smallest value. So 9 minus 1, 8. So the largest score minus the smallest score. That is called range. So when to use the range? The range is used when you have ordinal data or you are presenting your results to people with little or no knowledge of statistics. And it is used in scientific work as it is fairly insensitive. It depends on only two scores in the set of data, that is largest value and smallest value. Two very different sets of data can have the same range. See here, the data have 1, 1, 1. Okay, 4 data having value 1, only one data having value 9. So what is the range here? 9 minus 1, 8. Largest value 9, smallest value 1, 8. Say we have another set of series of data. You can see here 1, 3, 5, 7, 8. Here also, if you take largest value is 9, smallest value is 1. 9 minus 1, 8. So here the data, how it is spreaded, you can see here. The first series, all the data almost except to last value, remaining all the values are same data. Here the numbers are varying in the second set of data. But both the series, we have the range as 8. Next one, interquartile range. It is defined as the differences of the upper and lower quartiles. And upper quartile is denoted by Q1. Lower quartile will be denoted by Q3. And interquartile range will be Q3 minus Q. Okay. So in the BBT, little bit corrections are there. Upper quartile always denoted by Q3 and lower quartile will be denoted by Q1. So upper quartile minus lower quartile, that is called interquartile range, Q3 minus Q1. And quartile deviation, the formula quartile deviation also called semi-interquartile range. It is how the differences between the upper and lower quartiles. For example, quartile deviation equal to Q3 minus Q1 by 2.